Hello, this is Alex Lickscheidel, student in Introduction to Online Teaching, and today I will talk to you about how to derive Boyle's law within the gas laws. When you look at data of a gas pertaining to pressure and volume, if you plot the pressure and volume of a gas, what you'll find out is that there's a correlation that is not linear. However, if a plot of pressure versus inverse volume is made, one finds out that the correlation is indeed linear at this point. And what this means is that this equation presents itself to a y equals mx plus b format. Specifically, y is the pressure, x is 1 over the volume, as shown right here, so we have 1 over the volume, and there's a slope associated with this line, which we call c. If we multiply both sides by v, we find out that p times v must equal the slope of this line. The linear plot ultimately implies that there is going to be any data points along this line, call it P1, V1, that must satisfy this equation. If you multiply that pressure by the corresponding volume, you should find that it equals the slope of the line. But this applies to any point on the equation, so you could actually have a second data point for which you can multiply the pressure times its corresponding volume, and that multiplication is guaranteed to equal the very same slope of the line that we get from the Boyle law correlation. In and of itself, this means that P1 times V1 must equal P2 V2, and like that we have derived Boyle's law.